You imagine.
All right, and I'm starting to record, so the conversations are fixing to be recorded.
So there'd be really entertaining for the moment. We're just trying to keep it focused.
All right, now that my technical difficulties, I hope, are under control and it is actually recording this, we'll see. So I got 2 PowerPoints that I want to cover with you. So we're gonna move a tad fast. But Friday, I do need you all to come to class on Friday, because we didn't have class Monday. So we will actually cover material in workshop that's new on Friday. So I'll do lab 3 on Friday too. And then y'all will do assignment by yourself and send me email questions and stuff. So, if we don't get through all the slide decks and everything, we can hit some more of it on Friday. And if I have to, I can adjust due dates, because missing a day of class kind of screws us up. But that's why all of my schedules say this is your tentative schedule, because that way I can shift if we're a day behind, rather than trying to force you guys to move too fast. So, generally speaking, I will never change a due date that will negatively impact you. It was always a positive change if I change something, giving you more time, not taking. All right, so I need to introduce you to a few concepts that we haven't done yet. We're going to talk a little bit about modules. And Guidebooks does modules in a weird place in the content. So there's not really a lot of reading on modules that I'm going to assign. You can go look for it. It's Guidebooks. I don't understand the organization on this particular one. But modules are pre-made classes that you can use. They're in the standard library. You don't have to recreate them. It's stuff you can just go get and use and not have to reinvent the wheel as far as your own code. They're great. They're absolutely great. We've already used a little bit of them. The print statements are actually in a module that automatically loads. This input-output kind of thing. We've done some math. So there's a math module. And we can import the math module and be able to do square roots and stuff like that. I can't, my mind just went blank on math terms. So, but advanced math concepts are already out there, so you don't have to do it, raising something full power, that sort of thing within the math module. We're going to use one called Turtle. We're fixing to import the Turtle module, where we can draw with turtle graphics and have a cute little turtle drawing us pictures. This is very important because our first project is coming up, and our first project is done with turtles. You're going to use a turtle to draw me a picture, a very specific picture. I'm going to tell you how to. We'll talk more about it as we get to the project. But before we get there, I want you to practice with it some, so our next few labs are going to have some turtle elements too. So there is actually a link in the slides that will take you to the standard library. And I want to show you that real quick. So this is the Python standard library documentation site. You can get the link from the slides if you want to, because all the slides are there for you to download and look at your convenience. Or you could just Google search Python standard library and you'll get here. Or you go to the python.org page and it'll get you here. But it's very useful because there is a lot of things in the standard library. A lot of things. A lot of things in the standard library. Now, we are going to be doing a lot with turtles, but that's not actually the only one we're using. We use string a lot. So if you need to find something, there's a quick search function up here. I highly recommend the search function because there's a lot of stuff in there. Say I needed to find some more information about functions I can do with strings. I can put string in here. And it brings me up the stuff that has to do with it. I specifically want the string one. And if I click on that, that opens up yet again another mass quantity of information. But this is all of the string functions and how to use them. Right? So like if I needed the length of the string, I can come in here and look things up. I also can put and I get the turtle graphics and it tells me a little bit about it in general. Then it also gives me a list of all the functions that are linkable. So you can get more information about each independent function and be able to use them. Right? So turtles know stuff already. They know how to move themselves around and get places. And this is going to be useful because we're going to use them. But also when we get to the projects, you can look stuff up in here that might help you that I'm not going to tell you about. Now, there's a hard way to do it, and then I did some research and did an easy way to do it. So keep this in mind because you are going to need the turtle. I'm not going to give you everything you need for the project. You are going to have to look up at least one thing in here for your project when we get to it. So to use a module, we have to tell Python we're using it. So we're going to use an import statement. We're going to import that module into our code. So when we run it, it goes out and gets that information, and it doesn't give you errors about not knowing what a turtle is. So when we're doing turtles, the very first thing we're going to do before main, before we do any other piece of code, we're going to put our input statements. Why are we going to put them at the very top of our file? Because if you don't import before you use it, you're going to syntax it. Will Python let you put an import statement in the middle of your code? Yes. Is it good coding practice? In my opinion, no. So I like to structure my code, and you'll find as you go through this program that there are some guidelines that your professors enjoy using. Just make our lives easier. I always like to have a very clear outline in my head of what my code is going to look like. Import statements are first, and then I have a main, and then I go into functions, and I work it in that order. Python, I call it loosey-goosey because it'll let you do things in order I don't particularly like, and you get away with it. Python will also, when we get there, let you have more than one main function. And I'm going to say this probably every class from here until the end of the semester. Do not have more than one main function in anything you turn into me. One. This will make more sense when we get to functions, but I just thought I'd start early because it never fails. Somebody does this all the way through the semester. So, turtle graphics gives us the ability to put a little figure on our screen that looks something like a turtle, and we can draw with it, and we can practice concepts visually that we are typing code for. And somebody asked, why is it a turtle and not something cuter like a kitten or something? Because this actually dates back to the late 60s, when they first started introducing computer science and doing stuff with it more. And they realized that you can teach computing concepts to very young children as long as you related it to something they already had in their knowledge base. So most American children, and probably a lot of other children worldwide, knew what a turtle was. So they created a little robot looking thing that had a clear shell and wheels and they put a head on it and it looked like a turtle. And therefore they could relate what the turtle's actions were to relatively young elementary school age children and teach computing concepts in kind of a fun, playful way that they didn't know they were learning. If the parents in the room or people that have young siblings, it's much easier to trick a child into learning something by making it a game than it is to say, hey, we're going to learn how to do this. Because if your children are anything like mine, they put on their stubborn pants when you say you're going to do this. So that's why we chose turtles. It was something that people already have a knowledge base of. Because turtles, as far as I know, and I may be wrong, are pretty much worldwide. Different types of turtles all over the world. I could be wrong. So this is a sample of code, and one of the lines is messed up. So when you get down to this 150 units one, just know it's supposed to be over here, but the margins got me when I wasn't looking. So what this is we're going to start off our code on the very first line, and you can type all of this into idle if you want to try it, or you can, if you got the slides up, copy and paste it and edit it into idle. But we're going to import our turtle module first. This over here is a comment. So again, that line should finish that one. I guess I should edit this. Stop. Let's make the box bigger. There, that's better. So now they're all on the correct lines. So we're going to import turtle, which is our module, telling you we're going to open up all the different commands for us. Our turtle has to have a place to live, or in this case, it needs a graphic window to draw in. So the first thing you're going to do is create its world or its window. So this is all predefined functions. You don't have to write any of them. You just have to know to use them. And then once we've created its home to live in, we then create the turtle. I named mine Alex. Your turtle has to have a name, or you can tell it to do things. If it doesn't have a name, it's on the screen, but you can't actually do anything with it. Right? And then we can tell him to move, Alex to move forward, to turn left, and then move forward again. So if you want him to turn in a direction, you use the direction left or right. And then inside of the parentheses, you tell it how many degrees to turn. So all of you remember the when you were doing graphs and stuff in school, and you had to do the unit circle, and you got 360 degrees, right? So 90 degrees is yeah. If you want to go the opposite direction, if for some reason you don't want to change from left to right, you can use negative numbers and it goes the opposite. Everybody good on that? So a box, if I wanted to draw a box with my turtle, I would move forward, I'd turn 90 degrees, I'd move forward, I'd turn 90 degrees, I'd move forward, turn 90 degrees, because the internal angles of a square are 90 degrees, right? Theoretically. Hypothetically. I will tell you a little hint, sometimes when you're drawing with a turtle, you want the external angle instead of the internal angle. Not always, but sometimes. My math majors are all going, we understand this. If you have any trouble with the geometry, let me know, and we'll do a bit of tutoring on that, because some of us geometry was a very long time ago. All right, so everybody typing this now? Did anybody get this to work? Kind of cool, right? Doesn't look much like a turtle though, right? It's just a triangle right now. So there is a way to change the little triangle into a turtle graphic. And we can do, I'll show you how to do that, see as we go, because it's much more fun to watch a turtle than it is to watch a triangle. Anybody still typing this, or do I need, can I, okay. Yeah, it pops up as soon as you put it in the window thing. And now we put the turtle in it. If you had done it inside the pie file and saved it, it wouldn't have popped up for you to run. But because you're doing it in the shell window, it's just popping up as you.
Wait,
You can, you're just not gonna be able to save it. Yes,
So with this turtle getting it, it's trying to define it by degree.
yes, you define the turn by degrees. You can look it up. I'm not sure if if it is set in Python, but I know in Java, they actually have a predefined for 90 degrees. So you could do turn right or turn left and get a 90-degree one. But for our usage in Python, we just are gonna put the degrees in. If you want to go look up some other stuff and use it that I didn't teach, I won't count off for it, but you'll have to teach it to yourself. Because if I tried to teach every function, we'd be here. So next fall. All right, so I'm gonna move on, but like I said, you have all of these. So the turtle we created and the window we created are objects. So this is an object-oriented programming language, which means that we create objects and then our program acts through or on those objects. So all of our values in Python are objects. So anytime we create a turtle, we've created an object. Anytime we created a string, we've created an object. Those objects have attributes, which is a fancy word for properties. They know stuff about themselves. So in the case of our turtle, its attribute when it's created is its name, its variable name, and what the turtle knows is where to put itself. The turtle automatically, by default, draws in the center of the screen. The turtle knows its location in that screen at all times. That's an attribute that it keeps up with. When the turtle moves, it updates its X and Y coordinates. Now, if you're looking at that turtle screen, again, back to high school geometry, and we're going to have the center point of that screen is going to be 0, 0. So if you draw an imaginary lines through your screen, it's like you're, when you're graphing things, you have an x-axis and a y-axis, and 0, 0 is directly in the center. And your turtle is going to start out at 0, 0. Your turtle also knows which direction it's facing. It always starts out facing, if you're looking at the screen, it's facing to the right. If you're at the screen behind you like me, it's facing to the left when it starts. Why is that important for the turtle to know which direction it's facing? Anyone? Because if you tell it to move forward and you don't know which direction your turtle's facing, it might go in the opposite direction than you intended for it to. You have to be aware, and the turtle has to be aware of which way it's facing before it can make those turns and the drawing. Now, this is really hard for people that are not visual learners sometimes to plan out and map out in their head when they're drawing with a turtle. And I understand that. With a dyslexic child, I understand that. So if you need more verbal instructions or written instructions, let me know. But what we try to do, I tried to do with all this is give you a lot of steps to follow. But I will tell you this. Sometimes you will save yourself hours, and I literally mean hours, of frustration if you will take a pencil and a piece of paper and try to follow your directions with a pencil and piece of paper and sketch out what it's doing before you start coding. Or draw yourself a picture of what you're trying to accomplish and figure out what you think the commands are to do that. Because you'll often find that, oh, wait, I needed that external angle instead of internal angle. And, oh, I'm going to get left instead of right. So I know most of you aren't going to believe me on this, but 30 minutes of planning will save you hours of frustration. But let me put it the other way around. Hours of frustration can be eliminated by 30 minutes of planning. So keep that in mind. Remember that objects always know things about themselves. If you think about yourself as an object, you know you as a person have a name. You have identifying characteristics that make you unique. So objects have the same thing. There's a link directly to the Turtle API or the Turtle Standard Library section. I think you should keep this link handy for the next few assignments. It's going to help you out a lot. If you want your turtle to actually look like a turtle, if you do alex.shape and then put turtle inside of quotes, it will become a turtle. There are some other shapes. No, I don't remember what they are because I've never really cared to use them. If you want to go look them up in the API, go for it. But there are also functions that let the turtle return to you what its X and Y coordinates are. Those come in handy when we start drawing pictures where you know where your turtle is. And you can do the math on where you want it to go. There's also a function called goTo, where you give the function an X and Y coordinate that you want the turtle to jump to, which is also greatly important. So we have functions that we've been using, and we haven't talked about them a lot. We're going to start talking about functions more in depth in the next week or two. But these are all functions that we have used. Begin fill is the name of the function. The parameters are the things that go inside of the parentheses. Some functions have nothing in the parentheses, which means they don't need any information to run. They can just run as is, like begin fill. That means it's going to start filling in whatever shape you're creating. It doesn't need to know anything before that. Shape, it has to have a parameter called name, what the name of the shape you want to turn into. In our case, turtle. GoTo takes an X and a Y, and they're separated by commas. Xcore doesn't need any parameters because all it's doing is returning the current value of X where the turtle is currently sitting. I can't judge by faces whether or not y'all are getting this. So if you're with me, give me a thumbs up or nod at me or something. If you're completely lost, let me know that too. All right, mostly thumbs up. I got some blank stares still going, but if you have questions, now is perfect time to ask them. If you don't feel comfortable asking them in class, jot them down on a notepad and send me an email. Or you can come by my office hours. I'm in my office from 1 to 3, Monday, Wednesday, and Friday. All right, so pin down and pin up are things you're also going to use for your turtle, because if you put the pin down, the turtle draws a line when it moves. If you pick the pin up, the turtle just moves. And that's great when you're drawing because you don't always want a line when you're repositioning your turtle. If you forget to pick the pin up, you'll have random lines. If you leave the pin down, forget to put the pin down, and you drew an object, you go, oh, it's not there. It actually probably drew it. You just forgot to pin down. Go check for that. Yes, sir.
What's the difference between just a go-to and then pen up movement?
All the pin up does is picks the pin up. It doesn't actually move anything. The turtle sits exactly where it's at.
So, okay. So essentially, if you were to follow up a pen up with a movement like go forward 100, it would be similar to a go-to, just without specifying exact coordinates.
Yeah, but forward only moves. In a straight line.
Yes.
So I think what you're doing is overcomplicating things. All pin up does is fix the pin up. Anything after that still functions the same way that it did before. It just doesn't leave a trail.
All right, fair enough.
So functions have return values, or some of them do. And anything that has a return value, like when we were doing our input statements, that had a return value, it returned whatever the user typed. So if it has a return value, you have to set it equal to a variable to hold it. If it doesn't have a return value, it just does the action. You don't have to necessarily save anything because it's not giving you anything back. So most of what we're doing with the turtles are not necessarily going to have a return value. The X coordinate, the Y coordinate, the speed function, those have return values because you're getting information from the turtles. And to be able to use or see that information, you need to store it in a variable, just like our inputs. And then once you store them into a variable, you can print them out to the screen using those throwaway print statements where you can see what's going on. Or you can do some math with them if they're numbers, just whatever. You can also give your turtle text and stuff, and it will print to the screen. You can give this, there's all sorts of things you can do. There's all sorts of things that the turtle is going to be able to do that I'm not going to ask you to do. And there's going to be some stuff that I ask you to do that if you spent some quality time researching, you might could find a way to do it quicker than what we can do in class with the knowledge you have. The reason I do this, practice, I want you to practice things. And also I want to teach you to be independent programmers. I want you to be independent enough to go look things up and find solutions, because I don't know a programmer in the world that knows every function out there for any language. You always have to go look things up. You're always expanding and adding to and taking away functions from languages. Those appreciate functions sometimes because somebody makes something that works better. So learning to use the API is a very valuable tool. You can have multiple turtles. Yeah, I know this is hard to read and I didn't really intend for you to type it in class, but if you want to go grab the slides, feel free. But right now, we created, if I can make this bigger. I can. So this code creates a turtle named Bob. It changes Bob's shape to the actual turtle shape. Gives the turtle, it randomly gives you a random color, and the turtle is solid. So if you make more than one turtle, they're going to be different colors. So if you don't like the color of your turtle, you can change it. And you can change it to 2 tones. You can make the feet and head one color, and you can make the shell one color. I'm going to be honest, I don't remember what order they are. I always have to test it because I don't use it that often and figure out which one's which. But so if we wanted our turtle to be, show school spirit and make it red and blue because that's most of those colors, we could change the color of our turtle to red and blue and you'd have a 2-tone turtle. Let's say, hey, you like pink. You can change your turtle to be pink and purple. Whatever you want to do. So I can use the up function, which will pick up the pin. I can use the go to move it to a specific location. I can put the pin down and then I can draw pins. I also could put a second turtle out there. How would I go about putting a second turtle out there? I would use the same turtle.turtle command, but I would give it a different name. If you use that command again and use Bob again, it just overwrites the first one. So always give your turtles unique names. Don't do like George Foreman. Don't name all of your children George. But that's an old joke. I know. He really did. He named all of his children George. I'm assuming they had different middle names. I have no idea. But if you want more than one turtle, give them unique names, show them a little love, give them personality. Change their colors if you want to, but they will actually, unless you create a lot of turtles, come in different colors. Generally speaking, they're going to be a randomized color every time you create one. Not truly random. There's some math involved back there, and it's a computer, and computers don't do true random. I guess if you created enough turtles, you will eventually duplicate a color. But if they have unique names, you can access that turtle to do things. So, does this make sense? Cool. All right, so that's all my turtle slides. Let's talk about some new computer science stuff. So iteration. Iteration is a fancy word for we're going to repeat something. We're going to iterate or go through the steps. So what you really could call this is loops. And if you've noticed in Zybook, I only put one assignment up for this week, and had multiple chapters before. I did that for a reason, because we are going to do some chapters out of order, and I try to keep you from going, oh, I didn't do that reading, I did this reading, because sequential. I'm trying to help you out. So we're doing this chapter in Zybook slightly out of order. We skipped a chapter. Maybe two. But no, I know we skipped one chapter. We're going to go back to that chapter, just not yet, because I like to teach things in different order than our book is laid out in. So don't panic that we skipped a chapter. We're going back. I promise. The only thing we're going to skip is the stuff that says optional. So we want to learn some concepts that are key to good programming. You don't absolutely have to do those to program, but if you want good, clean code that people will like to read and like to use, these are some good things to follow. We want to use the drive principle. That's don't repeat yourself. You don't want to type the same lines of code over and over and over again. If you draw a square, you want to be able to use that code again or reuse that. So this is where loops come in handy. Say I need the turtle to move forward and turn, draw a square. Well, those are repeatable steps, right? It goes forward, turn 90 degrees. You put that in a loop and do it 4 times, you get a square. And you don't have to write the same lines of code 4 times. So we want to get rid of any redundant or repetitive code. So we do something called refactoring. And we take code that's got way too many lines in it, and we make it into a more condensed, easier to read set of code. We're going to work on that as we go through. Refactoring is something that you'll end up doing a lot as you go through your career. are your studies in computer science, because the code you wrote last week could be improved with the stuff you learned this week. Right? So there'll be times where you go, oh, I learned something new that would make that so much better. And you'll go back and you'll fix it, or you'll refactor it into something that's cleaner and easier to use. In here, I'm going to force you to do a little bit of that, so you'll get practice at it. But we want our code to be as efficient and as clean to read as possible, because when you get out in the real world and you get your first job, you don't want to be the person that wrote really bad code and your whole team's going, I can't follow this. You want to be the person that everybody goes, oh, that's really cool, let's do that. So iteration or loops let us repeat statements. We're going to do the for loop this week. There's also a while loop that we're going to get to a little later. But so right now we're going to learn for loops, and we're going to concentrate on them. So a for loop does something for a count. So it's a counting loop. It has a variable that keeps up with where it's at in the loop, and it goes until it reaches a stopping point, which we will set. So if we know, for example, we're drawing a box, we want that for loop to run 4 times. So 4 would be our stopping point. Our variable is going to keep up with how many times it's run. So every time the loop goes, the variable increases. And when the variable gets to the stopping point, the loop stops. So it's formatted like this. It's got the keyword for. It has whatever the variable name is. You'll see me use I a lot because I'm old. And when I learned loops, the variable was called the index. And index I is short for index. So you'll see me use I a lot. I also will try to do better and use a real variable name when I can. But if you see me typing for loops with an I in it, it's short for index. So we have the variable name in and then a list. So if I have a list of items, I would put the list name here. And while that variable has not reached the end of the list, it will continue looping. Now that's a special case for a list. You ask me why I made you read about lists, because we're using lists in our loops. So this is a special case. It's going to touch, this loop is going to touch every element in that list. When it hits the end of the list, it stops. The variable each time through is going to hold whatever value the list has at that point and let you do something with it. So if I had a list of cities that I went on vacation and I wanted to print them out, I could do this with a for loop, and I could make the statements inside my loop have to do with printing each element. So here's an example. So for course in a list of courses, right? The square brackets indicate that it's a list, right? So in this case, my list has CS1300, Math 1113, English 1101. So this is a freshman schedule, right? So if I do this and I put print course as my inside statement, it's going to go through one at a time, and it's going to print each one on a separate line. That makes sense? Now, notice that the statement is indented. So anything that belongs to the for loop, any statements that need to happen with the for loop, should be indented under it. Indentations tell Python that these lines of code belong to the for. When you're finished with the statements that need to be in the for loop, you need to tab back out or revert, unindent, for lack of a technical term for it, and put the code back in line with the for loop. Now, it's really easy to forget to tab over, or to not tab over, tab out of your for loop and have an extra line in there. So be aware of that. It's one of the things I don't like about Python is everything is based on tabs. Do not use the space bar to indent your code. Use the tab key. Will Python read it if you use the space bar? Absolutely, but if you put 4 spaces in on one line and 5 spaces in on the next line, you're going to get a syntax error that you can't see, because it is really, really hard to see if it's one space off. And then you and I will sit there and I will have to go through your code with you, or make you go through your code line by line with the arrow key going down to make sure that they're all in line. I do this every semester. Use the tab key. Please save yourself some heartache looking for that one space you're off, and use the tab key. This is also why if you copy and paste code from my slides, you need to be really careful, because the tabs in PowerPoint are not the same tab size as the tabs in idle, because Microsoft. There's more formatting there, it's different. And then you'll go, oh, well, I copied and pasted exactly what they said. Yeah, but your tabs don't match the rest of your code. Tab keys. We all love tab keys. This is not a problem in other in your next language. If you take the Java class, this won't be a problem because they do it completely differently. So make sure that you have the indents done correctly. Right? We're gonna get a lot of practice on this. It'll be fine. So you can manually list you can manually type out the list in your for loop if it's a short list, or you can have if the list is created with and it's got a name associated with it, it's in a variable, you can put the variable next to it. See, I show that because I use I as the index, because your list has an index, right? Because each element in the list has a position. So one other thing that you need to be aware of, computer science starts counting at 0. So all you mathematicians are going to hate me for this. But the index of 1 is 0. So the position of the list for 4 is 3. So be aware that you get what we call off by 1 errors a lot in loops, because people forget to accommodate or account for computer science and computer programming languages starting at 0. So like if you look at your content page, I usually have a week 0. I think I put dates in this time instead of numbers, but if I numbered my weeks, I would have had week 0 as the syllabus week. You'll often see those of us that have done a lot of coding and computer stuff that we start off at 0. Week 0, week 1. Week 2. Why? Because we have to represent 0 as a number. It does exist. It's not imaginary. So that's what we do. So you'll often see us do stupid things like start counting at 0, 1, 2, 3. I did code 5 times, but 4 numbers. Or the 4 is the next one. All right. We're gonna have a range function. So if we're not dealing with lists, if we just want the loop to run a certain number of times, we're going to use the range function. So we do for I in range, and then we can give it the stop values, or we get it a start, stop, and a step. So if we just wanted to count 4, we would just put the stop value there, stop at 4. If we wanted to do from 5 to 10, we put a start value and an end value. We wanted to do from 5 to 10, but we want to count by 2s. We would put a start, a stop, and the size of the steps. With me? Not with me? I promise we're going to practice this. Promise. Annoying you again. All right. So if you want to look up range, you can click on the slide and it'll take you to the API, give you more information on it. Please download these slides and use the links. So here's some examples of in range. So if I want to count to 4, I would just do for I in range 4. If I want to do 10 to 15, I put the start and the stop. If I want to do from 0 to 11, counting by 2, put the start, stop, and the step size. And if you're like me, this is not going to sink completely in until we actually do it. So on Friday, we will do a lot of examples and we will write code. I'm actually going to save the refactoring part until Friday because we haven't actually wrote the turtle box stuff yet. This is in lab. So when we do the lab, I will also be recording that too. And we'll talk about refactoring when we start working on the lab. Because it's easier to show you that than to talk about it. So I'm going to make you write it out the long way and then make you go back and fix it. And you're all going to go, I don't want to do it. It's good practice. Good for you. The more you do something, the more apt you are to remember it. Because studies have proven that it takes 5 times of repetition for it to get into your long-term memory, 5 or more times. So if you do something multiple times, it's more likely to stick in your long-term memory than just be in your short-term. All right, I'm pretty much done for today. Like I said, we're gonna do the refactoring of the turtle box here in lab on Friday. Anybody have any questions, or did I confuse anybody to the point that they want to pull their hair out yet? Would you ask me questions if you had?
Yes.
Thank you. What I need to hear. All right. See you all on Friday. Remember, we meet at